In this part, and after we had made the calculations for the field or border irrigation dimensions in the previous part, we will input the data and parameters or the border dimensions for problem 3 for designing the basin irrigation in the NRCS Surface program. We go to the field topography over geometry menu. Then in the field geometry, we input the field length, which is 366 meter, as we see. Then we input the field width, which is 365 meter, as we see. And for the field cross slope, we choose 0. And for the border unit width, we choose 1 meter. And for the downstream boundary, we choose free draining. Then in the Manning end values, we type 0.18 for the first irrigations and for the latter irrigations. Then in the compound slopes, we type 0.002 for the first slope, second slope, and the third slope, as we see. Then for the first distance in meter and for the second distance in meter, we type 366, which is the length, which is the border length. Then we go to the infiltration characteristics menu. Then in the initial continuous flow conditions, we press on the tables. And the intake rate is 0.54 inches per hour for this problem 3. Then for the intake curve, we choose 0.5 for silty loam soil, then OK. Then we go to the 2 points, and in it we input the TL, which is the time that the advanced phase needed to arrive at the end of the border, which is in this problem 3 equal to 276 minutes. Then we input the 0.5 TL, which is the time that the advanced phase needed to arrive at the middle of the border, which is in this problem 3 equal to 125.5 minutes. Then we input the 0.5 L, which is the half of the border length, and it can be calculated by using the calculator as follows. As we see, so in the 0.5 L, we type 183, then we press on the tab key. Then we press on the 2 point. Then we input the root zone moisture depletion 0 Z-rate in meter, which is 0.1. As we see. Then we press on the tab key. Then the required intake opportunity time in minutes appears. Then we go to the inflow controls menu, and in it we specify the options as we see. Then we return to the design panel menu. Then from the calculations for this problem 3, the total number of borders is equal to 20. So we divide the field into 20 borders as we see. Then the run width becomes 18 meter and the run length is equal to 366 meter. Now we go to the input data for design. Then we input the total available flow in liter per second, which is 283.33 liter per second. Then we input the total time flow is available in hours. And it is not available And this problem 3, so for the total time flow is available in hours, we type 96 hours. Then we input the max velocity in meter per minute, and this value depends on the soil type of the border of field. And from a little while ago, we specify the soil type of the border according to the intake curve, which is 0.5 inch per hour for silty loam soil. So for silty loam soil, according to the table, is 39 feet per minute. So we transform it to meter per minute by dividing it by 3.28 as we see. Then the max velocity equal 11.9. Then we input the design flow in meter per second per unit width, and this value exists in the problem 3 data, which is 3.69 liter per second per minute. Then we input the cutoff time in minutes, which is 240 minutes. Then the total irrigation time in hours becomes 80 hours, which is less than the total time flow is available, which is 96 hours, so it is okay. Then we save the design of the basin by going to the File menu. Then we press on the Save As. Then we go to the project file on the desktop titled NRCS Surface, and in it we type the save name, which is problem 3. Then save. Then we make the simulation by pressing on the Simulate Design in the Design Panel menu, as we see. Then the simulation is done according to the design that we did in the INFLOW control menu. Then the simulation results appear, which includes application efficiency 46.98%, irrigation efficiency 46.98%, requirement efficiency 68.21%, distribution uniformity 93.77%, tailwater fraction 53%, and the depercolation fraction 0%. And for volumetric balance in cubic meter, the inflow 53 is 53.1, outflow 27.7, and the infiltration 25. Then the error percent is 0.9%, which is less than 5%, so it is okay. Then we save the design by pressing on Save. To preview the results, we go to the Output menu, then we press on the Display Output Results. Then we tick on the Advanced Over-Precision over Cumulative Intake, and we preview the results in the table as we see. Then we tick on the tailwater hydrograph over end depth, and we preview the results in the table as we see. Then we return to the output menu. Then we press on the plotted results and we preview the plotted results as we see. By that, we have finished designing the free draining border irrigation for problem 3, and we will continue the design of surface irrigation types in the next parts.